apologise, this room's really warm by the end of the day, so we'll try and get you into the nice cool bar for the drinks afterwards quite soon. Right, it's my great pleasure to be introducing the last session of today. We've got two sets of talks for you. The first is by Hannes Kindbom, who's from 9fin, a growing fintech here in London. And he's talking about improving complex RAG systems and achieving no-regret, lightning-fast deployment iterations of LLMs. He's got a master's in both machine learning and applied mathematics, and he works as a full-stack data science at 9fin. He's very product-minded, got a ship-early mentality, and has got a background in NLP, LLMs, information retrieval, and data engineering. And he's worked both on the research side, model development, and implementation. So over to Hannes.
Hear me? Okay. Yeah, great. So welcome everyone to my presentation called No Regrets, Safely Optimizing Complex RAG Systems with Lightning-Fast Deployments. My name is Hannes Kindbom, and I'm a full-stack data scientist at 9fin. 9fin is a data and analytics platform for leveraged finance, which is a specific type of finance which is about bonds and loans and so on. So we basically collect a bunch of data, process it, and then make it available on our platform and sell that as a subscription model. We also have our own analysts and lawyers writing analysis and publishing on the platform as well. Before I dive into this presentation, I'll quickly describe a bit more about myself. So I'm born and raised in Stockholm, Sweden, and this is a picture of me wearing a quite traditional midsummer hat with flowers. As mentioned, I have masters in machine learning and applied mathematics from KTH Royal Institute of Technology, and that's a picture of my uni in Stockholm. On the spare time, like to travel, so here's a picture of me overlooking the Halong Bay in Vietnam. Pretty cool place if you haven't been. And have a background in InsurTech, and this is actually an old ad from my previous company saying go get in trouble, quite different from the typical message from traditional insurance companies. In terms of my skill set, mainly focused on NLP, LLMs, information retrieval, data engineering, mostly writing code in Python, and experience with GCP and AWS clouds. And that's a picture of Amazon Alexa that I worked on during a university project. So in terms of the agenda, we'll start off with a quick introduction to RAG, Retrieval Augmented Generation. Then we'll move on to how RAG systems are optimized and evaluated today in the industry. And then I'll show you how we can move beyond that and take the next step to safely optimize and deploy RAG systems in production. I'll wrap up with some limitations and disclaimers, and finally some key takeaways as well. First off, I'd like to say that LLMs are very powerful, but no one is perfect. And as you may be aware of, training these models is very resource intensive, and therefore it's not done very frequently, leading to outdated knowledge. I think we've all seen answers such as, sorry, I can't answer due to my knowledge cut off in 2021, etc. So that's a limitation. Another one is that they are typically not aware of your data, your proprietary data you may have behind password protected databases, because common LLMs like OpenAI's GPT-4 trained on enormous amount of public data, but not your private data. And then a third limitation I'd like to highlight is the latency, which is often a problem, and it's correlated with the number of input and output tokens. Then we have the limited context window, and although we've seen recently context windows growing up to millions of tokens, for an organization, usually all of your data will not fit in one prompt. And whether that's a good idea to stuff everything in one prompt anyway, that's a separate discussion. But as mentioned, a huge prompt is related to latency as well, so maybe not the best idea sometimes. So a popular solution to tackle these challenges is RAG, Retrieval Augmented Generation, which is essentially an LLM attached to a knowledge base through a retrieval system. And with a RAG system, we can move from outdated knowledge to fresh knowledge, as long as we keep the knowledge base up to date. We can also make the LLM aware of your data, because we're retrieving from your proprietary knowledge base, perhaps. We're retrieving information, inserting it into the prompt, so essentially making the LLM aware of your data. We can also achieve lower latency, because we don't have to maximize the context window. We can hopefully just retrieve the most relevant documents and use that in the prompt. And we get around the limited context window, because we only retrieve a subset of the data for every query. And to concretize this, I'd like to show you a real-world use case of RAG, which we call 9FinAI. And it basically works like this. You can ask questions about companies, such as what's the adjusted EBITDA of Six Flags. EBITDA is like a financial metrics, and then Six Flags, that's a company. So you get the answer, and then with a link to the sources as well. So today I'll show you some of the secrets behind the success of 9FinAI and how we're able to iterate so quickly on this feature. But first of all, I'd like to just quickly show a common RAG architecture with some common components. So you have a user with an incoming query or a question, and then you might have a query understanding or routing component where you can have an NER model extracting entities. You can rewrite the query, add additional queries, and maybe route it to different retrieval paths based on the type of query, and so on. And then as a second step, you can retrieve hopefully some relevant candidate documents from your search index, and maybe in combination with some data from an API. Let's say the user asks, what's the current weather in London, and then you might use an external API for that kind of information. And then pass it through a re-ranker here in the middle, or a cross-encoder, which is a bit more computationally heavy. So you just use it on your candidate documents to further rank them by relevance. Then pass that in the prompt template along with the query and get the answer from an LLM. And then in the background, you need to keep the index up to date, so you can have source data maybe in SQL tables or S3 buckets that you need to, could be like PDF documents or tabular data where you extract text, chunk it, and maybe enrich it with metadata as well, and then index into your search index. So as you can see, RAG systems are pretty complex with multiple components to optimize here. And you will have lots of questions to ask yourself when you develop on these systems, such as, how many candidate documents should I retrieve? Should I use semantic, lexical, or hybrid search? Which entities should I try to extract from the query? Which LLM is optimal for my use case? And for example, which data do I need to add next? And the list goes on. And these questions will make you sweat. And I've experienced this myself. So due to its complexities, deploying changes to a RAG system is scary. How do we know that the next version is superior? How do we know that there are no critical bugs in some of these components? And how do we know that the latency is acceptable for users and so on? This is while the industry is quite focused on new, more advanced chunk strategies, embedding models, and to some degree also offline evaluation. And I'll first show you some interesting offline evaluation techniques I've seen to test your system before you go to production. So for example, you can collect tuples or pairs of relevant chunks and irrelevant chunks, and then you can evaluate your retriever based on how often it ranks the relevant chunk above the irrelevant one. Because it's a bit easier to collect these tuples rather than trying to find ground truth relevant documents in your full search space. You can also use the LLM as a judge, quite common technique, where it can maybe vote on different versions of your system or rate different answers. So these are some techniques you can use for offline evaluation before you go to prod. And there are some great frameworks as well that you probably heard of, Llama Index, LangChain, with some documentation as well that you can check out for inspiration. However, we can leverage evaluation data sets and test the system in staging, but there are some problems. First of all, around the data. As mentioned, it's very tricky if we want real ground truth, to collect relevant documents given a query due to a vast search space. So for a human to go and find the relevant documents, very tricky. Also, there is often no single good answer to a question. So even if you try to write a reference answer, a ground truth answer, how do you compare a generated answer to it? Because the same question can have vastly different but acceptable or good answers. And then, as much as we wanted to, test data is never going to be the same as production data. There are also the users. And the users can be pretty unpredictable. And it's quite hard to think about all edge cases when we're writing tests. Because also this is something I've experienced, that some users will deliberately go and try to find bugs in your system. And it's going to be hard to test all of these edge cases. It's also quite unclear what latency is acceptable for users. When I've used different RAG systems, I've seen latency from maybe 3 seconds up to 20 seconds. And me personally, I would lose patience with a 20-second latency quite quickly. But it varies depending on the type of user. There's also kind of a cold start problem here. So when you first deploy the system, or when you expand, let's say you expand your search space, add more data, what kind of questions will users ask about on that data? So all in all, I'd like to say that the real test is in production. And that's also where the solution lives that I'm going to demonstrate today. The solution that will help us lower the barrier to production, help us optimize the RAG system in production with real users and real data, and achieve lightning-fast deployments. And to do this, we're going to stand on the shoulders of giants. And more specifically today, we're going to focus on the AWS Lambda technology. For those of you who are using Azure or GCP, you have similar technology in Azure Functions and Google Cloud Functions. And to recap, an AWS Lambda is a way to deploy your code without any server management. You also have auto-scaling, so depending on the traffic and demand, it's going to scale up server capacity. It's also pay-as-you-go, you only pay for what you use. And more specifically, or more importantly today, it has support for aliases, which is basically an alias or a name of your function that's pointing to a specific version of your code. And that specific detail is what we're going to use today. So the solution looks like this, essentially, that we're going to use the lambda as our kind of like our main.py, or our main function, our entry point, and our orchestrator of the RAG system. So the lambda is going to hold the prompts, the request details, configurations, lots of different if statements, credentials, and so on. And then outside of the lambda, we're going to have the search index, the LLM, maybe an NER API or model. Because the lambda is really great technology, but it's not good for heavy things, because it doesn't have a GPU, it has a memory limit, and so on. So this is the setup we're going to use. And then we're going to go and create 2 aliases, one live and one shadow. The live alias is our stable RAG version. And behind the shadow alias, we're going to have our experimental RAG version. So as mentioned, each alias is pointing to a specific function version. So live might be pointing to function version 3, and shadow might be pointing to the upcoming next version 4 with a certain commit SHA of your code. So that's going to be the setup. And then we can interact with shadow in 3 different ways that I'm going to demonstrate. And the first one is to asynchronously invoke shadow and log responses for offline comparison. So to simply illustrate, looks like this. You have your client with a query. You send the query to both your live lambda and your shadow. And then you just log the responses for both, but you only show the answer from your live version. So in this way, the user is always going to get the live response, but you can try stuff out in shadow without having a user impact. And you can still compute metrics offline and compare responses. This is a good first step, quite easy to implement. And then the second approach is to use the shadow for some beta users with feature flagging. You can, for example, use third-party providers for feature flagging, like LaunchDarkly, for example, where you have a subset of users, could be internal users or maybe some users you have really good relationship with that will actually receive the answer from your shadow RAG system. And this requires beta users, which you might not always have, but if you do, it's great to get qualitative feedback, because some users will actually see your experimental version. And then the third approach is to do A/B testing. So you can randomly select, let's say, 20% of users and show the shadow response to those. And then the remaining 80% will get your live response. And this is a bit more suitable if your usage is high and you also have like a clear target metric for tests of significance. This can also be used as a last step, maybe after you've done some beta testing with the feature flagging. You expand it to more users. So we love graphs. So this is a graph showing on the x-axis implementation difficulty, on the y-axis user experience risk. So as you can see here, the third approach, A/B testing, has a bit more difficult to implement. And it has also higher user experience risk, because you take a random subset of users, and if there is something wrong or bad with your shadow RAG system, that's going to affect a random set of users. While the first approach, asynchronously invoke shadow, it's very low risk, because it's always just happening in the background. No one is seeing this anyway. And then in the middle, you have the feature flagging with beta users, somewhere in between. And I put a star here because that's my personal favorite. I love to get the qualitative feedback, because you can try to measure everything, but it can be hard sometimes. So then we need some metrics here to be able to compare live and shadow before we replace live with the shadow version. I've just highlighted some areas of metrics here, where the first one is latency, which I mentioned a couple of times, very important to compare on latency. You can also compare on percentage of questions where a relevant source was retrieved. Different ways we can do this, for example, look at how often is the LLM referencing our sources, or how often do we even retrieve sources. Then you have to bottom left the percentage of thumbs up and down, and this is mainly useful if you're doing A/B testing to avoid having bias between the groups. And then to the bottom right, you can do either manually walk through the live and shadow and compare, or you can leverage an LLM to speed this up and rank live and shadow, or assign scores to them. So in conclusion, this is the RAG development cycle that I suggest, and I bolded the new additions here. But basically, first of all, you update your RAG system, make the changes according to your hypothesis. You can do local evaluation and tests, and then do some testing and staging as well. And then deploy to shadow in production with one of these 3 strategies that I walked through. And then you just check live versus shadow metrics. And then once you've proven that your shadow RAG system is superior, you go ahead and replace your live with the shadow version. And then you just go over again. And this is how we can safely optimize complex RAG systems with lightning-fast deployments. So on one hand, we achieve no regrets, because bugs in shadow have 0 to minimal impact on user experience, depending on the type of strategy you choose. And then on the other hand, we also achieve lightning-fast iterations, because we've lowered the barrier to production, meaning that we can ship early and experiment with real data and real users, and this will ultimately make progress. We will make progress faster, because it's not as scary anymore. And before we wrap up, some limitations as always. First of all, this setup is a bit more costly and complex. First of all, to set it up, to code it, and then you also have to maintain these 2 API interfaces, and also because on every query we're, for example, sending to running the LLM twice as much, so consuming more tokens. We also have some increased database pressure, or pressure on your search index, and especially if you're writing data to any databases, be careful with conflicts or data pollution. Then a third limitation is that we can't version control everything inside the Lambda. So some components like the search index and LLM will have to live outside. So those will have to be version controlled separately. And some key takeaways then. First of all, RAG systems are complex and offline evaluation is hard. And this makes production deployment scary. While the current industry focus is on offline evaluation and improving the RAG architecture with new chunking strategies, embedding models, etc. So I'm suggesting that you go one step further. You make use of AWS Lambda live shadow aliases, and only then can you achieve safe, lightning-fast, dual endpoint deployment setup and production evaluation. I've also walked through which shadow strategies you can use in which case. So now it's time to open up for Q&A, and I'd also like to take the opportunity to say that we're hiring. I think we're pretty much going to double our engineering department this year. So if you're interested in these things or similar things, you can reach out to me or check out our website. But yeah, that's all from me today.
Thanks, Hannes. Lots of questions.
Have you considered showing the two answers to the same user and getting them to choose which one they prefer, maybe for like beta users in particular?
Good question. That's nothing we have considered actually, but it's a good point. That's definitely a possibility that we can do as well.
Hi, thanks for the talk. You mentioned a lot about optimizing this RAG system in production. When you're doing these optimizations, is the focus entirely on the indexing system and the queries, or is there any work done on, say, post-processing to counter hallucinations?
A good question. Yeah, we're trying to optimize, all components, but the first step is to find out, okay, where is the current bottleneck, and then we focus our efforts there. So there are, different metrics you can look at for different components of the system. For example, on the retrieval side of things, you want to try to find metrics for how relevant the retrieved sources are, as I mentioned, and then for the actual answer, you have different metrics. So yeah, look at both.
Sure. Thanks.
Related with the previous question, but it's about the choice of embeddings and how often and quickly you update them. Like, do you prefer big embedding models, small embedding models? And how do you do that accuracy versus latency trade-off when you make those choices? And if you need to update the embeddings, do you just go and reprocess everything, generate using a different embeddings model?
Also a good question. I think it's a good idea to start off with some sort of baseline embedding model and then optimize from there. In terms of the trade-off between latency and size of embeddings, I think something you need to experiment with. That's also why this setup is great, to try to find out what kind of latency is acceptable for your type of user. And then to try to make that trade-off. Can't go into detail what kind of model we're using exactly, but this setup should allow you to run those experiments that you need.
Hello. Oh, sorry. Am I next? Great. Thank you very much for a super interesting talk. Super clear, really great overview, and we've actually been also recently thinking about this particular question, so it was really interesting to see your approach. Just a couple of questions. First one is around hallucination, which is maybe just a general sort of RAG thing, an LLM thing, rather than specifically around the changing the production environment. And specifically, I saw in your demo that your tool also provides these very specific answers to very targeted questions, like what is the EBITDA of Six Flags? And obviously, how do you feel about the certainty that the model never gets those kind of answers wrong, even in a RAG environment? I mean, is there any kind of testing that you've done to sort of see that, well, we know that less than 1% of the time it will get the EBITDA of a publicly listed traded company wrong. So just that kind of key remaining risk of hallucination and how you think about that. And then one more question, if I may, around the serverless architecture for the Lambda functions. Is there any reason why you prefer the serverless architecture over like a microservice API?
Yeah, good questions. I think in terms of the hallucination, it's always tricky with these models. First of all, I think one important thing is to make sure that you have the references to the sources and that it's kind of like a UI thing that if you're using chunks, maybe allow the user to see like which individual chunks are used in the answer to be able to validate. I think that's kind of like the audit trail is very important to gain trust. But to completely eliminate hallucination is tricky. There are various techniques for it. So just need to do some experimentation there, I think. Your second question around serverless versus, do you mean, for example, like an EC2 or something like a fixed machine? Yeah. I think it kind of depends a bit, maybe, on how much your traffic is changing over time. If you want this kind of auto scaling, so that's one thing. For example, for us, the financial market is closed during the weekend, so we don't need to have a lot of server capacity, whereas on a weekday and daytime it goes up significantly. So that's one factor to consider. But yeah, I guess you could, if you're using a bigger machine, you could potentially have more of these components inside of this main code base, so you can version control maybe more components. Hopefully that answers your question.
Any other questions? I've just got one. I think you can configure Lambda to basically do blue-green deployment over time and just roll back on CloudWatch logs. Would you ever consider doing that?
You mean to do use the built-in traffic splits?
Yeah.
Or yeah, that's something you can do as well. I think it depends if you wanna. I think it depends if you have a dedicated third-party provider like LaunchDarkly to do it, or if you want to use the built-in. I think you can probably use the built-in as well.
Okay, cool. Any last questions? No? Okay, let's thank Hannes again.
Thank you.